what we're going to be looking at next is one of the ways, or a way, for transitioning from one type of concentration unit to another type of concentration unit. You may be reading a research article that used mole fraction, and you're doing your experiment using percent by mass or something like that. Or maybe you purchase a solvent or a solution that's in molarity and you need to know the molality. So there are times we need to switch back and forth amongst these concentration units. And I think one of the key things to realize when you're doing this is that all of these are intensive. So we're going to often be assuming a convenient starting amount. You may be given a starting amount, but more often than not, we're going to have to assume a given amount. And when you're setting up the problems, you want to set them up as full formulas. You don't simply want to write molarity equals. You want to write molarity is equal to moles per liter of solution. So you realize that in order to calculate this, you somehow have to get the moles and you somehow have to get the liters of solution. Now, here's my guideline for doing this. If you're given molarity, some sort of molarity value, in this case, say 0.25 molar, what you want to assume is that you have 1 liter of solution. And that means you'd have 0.25 moles of solute that would be brought along with that 1 liter of solution. Now, if it was molality, your assumption, I think, would be the easiest, is that you have 1 kilogram of solvent. So if I have a 0.25 molal, I have 0.25 moles of solute and 1 kilogram, remember that's of solvent. You have to be very careful with that. For percent mass, we've done this before, the easiest number to take the percent of is the solution, which means that you not only know that you have 100 grams of solution, but that you have 25 grams of solute and hence 75 grams of the solvent. And that's going to be a critical assumption and critical formula there. For mole fraction, you want to assume that you have a total of 1. And so if you have a 0.25 mole fraction of solute, that means you have 0.25 moles of solute and 0.75 moles of solvent. So those are going to be our assumptions that we're going to be starting with in each of these problems. Now, I've worked hard on trying to find a better method, and I think I did this year. So we want to start setting up some sort of problem-solving grids. We'll do this later on, especially when we do equilibrium. But remember, we did this earlier. You effectively are setting up a grid when you solve the mole road in stoichiometry, which you did last year, and we will see again. And so that's what we're doing here. And what we always want to start with is this formula, that the mass of solution is going to equal the mass of the solvent plus the mass of the solute. Now, there are times you may also use this formula, stating that the volume of solution is equal to the volume of solvent plus the volume of solute. Now, that's not always true. But it is a common assumption that will be made in these problems, and they usually spell that assumption out. Masses will not change on mixing, but volumes, because of attractive or repulsive forces, actually might change. Then we're going to fill out this table. So really what we have up at the top is, especially for mass, is that the mass of solution is going to equal the solvent plus your solute. So your goal is to fill out as much of this as possible. Now, we really won't be using a few of these too much. For example, you can't go from mass to moles of a mixture. That's only for a pure substance. We will be able to do it for our solvent. We will be able to do mass to moles for our solvent and mass to moles for our solute. And mass to moles, by now we use molar mass. There may be times, but it would be highly unusual, that you're given volumes, that we're talking about liquid solutes and liquid solvents, but the way to do that is via density. And by and large, this won't be used as much, but they are there for you just in case. Now, mass of solution to volume, This is going to be critical because the only way you can go from molarity to our other three concentration units is if we know the density of the solution. And so we'd be given the density of the solution in this case. So that's always the extra information that you need to know if you're going to go between molarity and the other concentration units. So when you come back in the next video, we'll look at some examples of filling in these grids and doing this type of problem solving.